Hello and Assalamualaikum. My name is Muhammad Samrin bin Jimmy. For today, I would like to show how to solve an SLEO system linear equation with 3 equations and 3 unknowns using Gauss-Jordan elimination method. So to use Gauss-Jordan elimination method, there is 3 main tips you will consider for finding the answer. First, work on column 1 first and get the leading one, and then after that use the row with the leading one to get 0 in the rest of the column. So let's get started with this equation. First of all, what we're gonna do is we need to transfer the equation to the augmented matrix. So we will get here 2, 3, 1, the constant is 3, and here we will get 1, 1, 1, 2, and the third row 1, -1, -2, -6. This is the matrix augmented after we transfer the equation. And so for the first tip is we need to get leading one on first row and first column. So what we can do to make leading one in first row and first column, we can do the interchange row between row number 1 interchange with row number 2. After we make the interchange, the new augmented matrix will be here is 1, 1, 1, and the constant is 2, and the second row is 2, 3, 1, 3, and the third row is unchanged 1, -1, -2, and -6. We already get leading one here, but the problem is we need to execute all the numbers on first column to make it become 0. So what the operation we need to do is we need to multiply -2 with row number 1 plus with row number 2 and put the answer in row number 2. So I'm gonna so here the operation will be like this. The first row is unchanged 1, 1, 1, 2, and here is we need -2 times row number 1. So I will put down here -2 times row number 1 and plus with row number 2. So this is -2 times 1 is -2 plus 2, here will be 0, -2 plus 1, -2 times 1 plus 3, we will get here 1, -2 times 1 plus 1, we will get here -1, and -2 times 2 plus 3, we get here -1. So we already settled down for the second row, second column, this one. So we need to move for this to execute this to become 0. What operation we need is we need to multiply the first row with -1 and then plus with row number 3 and put the answer in row number 3. So the operation will be here. So I'm going to execute this. I will change with -1. -1 times 1 is -1 plus 1 will get here 0. -1 times 1 plus -1 will get here -2. -1 times 1 plus -2 will get here -3, and -1 times 2 plus -6 will get here -8. So we already settled down the entire column, which is we get the leading one, and the whole numbers is 0. So next step, we move to second column. We are focused on this column. So this is very good because we already get the leading one, and the problem is just we need to execute this number to make it 0. The operation we can do is we need to multiply -1 in row 2 plus with row number 1 and put the answer in row number 1. So the new augmented matrix will be the second row is unchanged, 0, 1, negative 1, negative 1. So here is negative 1 row number 2, negative 1 times row number 2 and plus with row number 1. So negative 1 times 0 plus 1, we get here 1. Negative 1 times 1 plus 1, we get here 0. Negative 1 times negative 1 plus 1, we'll get here 2. Negative 1 times negative 1 plus 2, we get here 3. So next is this number, and the operation we can do is multiply 2 in row 2 plus with row 3 and put the answer in row number 3. So as you can here is 2 times 2 and plus with the row number 3. So here is 2 times 0 plus 0, and we get here 0. 2 times 1 plus negative 2, we get here 0. 2 times negative 1 plus 3 plus negative 3, we get here negative 5. 2 times negative 1 plus negative 8, we get here negative 10. So here we also fix this column, which is leading one and the entire is 0. Then we will move to the next step. Next step is we move to this column. We focus on this column and we get a lot have to do, which is first we need the leading one here and execute the numbers to become 0. So we will start here first. To make it become leading one, we need the operation, which is we are trying to multiply negative 1 of 5 row 3 and put the answer in row 3. So after that we will get here this first and second is unchanged, 0, 1, negative 1, negative 1, and here we will get, if we multiply with 1 of 5, negative 1 of 5, negative 1 of 5 times 0, we get here 0, negative 1 of 5, 0, we get 0 also. Negative 1 of 5 times negative 5, so we get here 1. Negative 1 of 5 times 10, we get here 2. So see, we already get leading one here, and the rest problem is to execute these numbers and this one. So we will execute this one first. The operation we need is we try to add row number 3 plus with row number 2 and put the answer in row number 2. So the new augmented matrix we get of the operation is the same, 0, 0, 1, 2. So here is row number 3 plus row number 2. So it's like here, so plus 0 plus 0, we get 0. 0 plus 1, we get 1 here. Negative 1 plus 1, we get 0 here, and negative 1 plus 2, we get 1 here. Okay, settle down. We already get the zero numbers here, and we move to the next numbers, which is this one. And the operation we need is try to multiply negative 2 row number 3 plus with row number 1 and put the answer in row number 1. So negative 2 times row number 3 and plus with row number 1. What we get here is negative 2 times 0, negative 2 plus 1, we get here 1. Negative 2 times 0 plus 0, we get here 0. Negative 2 times 1 plus 2, we also get here 0. And negative 2 times 2 plus 3, we get here -1. After we did a few operations, so we already get here the leading one for the first reverse color, and here also we already have leading one and the entire is 0. Here is leading one and the entire is 0. So back to our equation and put the variable for our matrix, which is this one is for x, y, and z. So this means is 1x plus 0y plus 0z equals 1, and the second one is 0x plus 1y plus 0z equals to 1, and here is 0x plus 0y plus 1z equals 2. So by this it means x equals -1, y equals 1, z equals 2. So we already get here the solution, and we call this as unique solution.